Hey, good morning, everyone.
Good morning.
Okay, um, let's let's wait some few minutes for your friends to get here. We have 40 in the meeting right now. Now let's discuss a little bit about the plan for today before we start recording. And please remind me that to start it. Otherwise, you will stuck with nothing to study afterwards. Today we will discuss some more about motion. Last time we start with um, distance and displacement, and then average velocity. So we will continue to instantaneous velocity and then acceleration before we study some example on motion. Okay. Then around 11:45, please remind me that we will have small quiz on vector. Will be about 7 questions, not that uh, not that long. So some will be easy to answer. So I think 15 minutes is enough for everyone to work it out. So let me set up alarm clock for that. 11:45. Okay. And I already have the link to the quiz already. So let's get back to our lecture. Okay. Oh no. So last time we start with okay, let me see, share screen, motion. Okay, let's restart the share. So last time we start with the concept of motion by giving a definition of a distance and a displacement. Now, a distance is the length of the path of motion, and the displacement is the vector starting from initial position to final position. So, in the meaning, they are different. Distance is a scalar quantity, only the length, the magnitude. But displacement is a vector quantities, and displacement consists of both distance, both magnitude. We must say magnitude and direction. The only situation where displacement is equal to Distance is when an object is moving in a straight line in one direction. For example, we have an example of a student walking in semicircle. And we find that a distance is half a circumference, which is pi r meters. But the displacement is actually the diameter, the length of the diameters from starting point to ending point. So the magnitude of the displacement is actually 2r, while the distance is pi r, which is the distance is longer. And in Cartesian coordinate, we discussed it already in vectors that a position vector can be represented by three vectors, the x, y, and z. And the position vector can be written in terms of xi plus yj plus ck. And when you want to find the displacement, all you have to do is subtract the final vector by the initial vectors, and you get a displacement vectors in Cartesian coordinate. If you want to find the magnitude, you use Pythagorean theorem to find the magnitude of the displacement. And also, well, if you divide the displacement by its magnitude, what remain is the unit vectors of the displacement, and that is given the direction of the displacement. Then we learn about the definition of the average speed and average velocity. And the average speed is the displacement distance divided by time, and the average velocity is the displacement divided by time. So it is the same as the distance, the displacement, the average velocity and the average speed are not equal because one of them are scalars and one of them are vectors. And also the direction are not the same. And we can find the average speed by divide the distance by the time, and in which we discussed the example already. And we introduce what we call instantaneous velocity. And that is basically is the average velocity between the time delta t, where delta t is approaching zero. And by doing that, the instantaneous velocity will have the direction tangential to the path. So we will continue from that. By mathematically, if, let me use the magnifier. Mathematically, if we define velocity as dr by dt, you can write it backward in terms of dr is v dt, and then doing an integration from 0 to t of v dt give you r I to rf dr. Doing integration on both sides, dot ri to rf dr equal to integration of 0 to t v dt. So the displacement is rf minus ri is equal to integration of v dt. So that is the basic formula or basic relation between the displacement and the instantaneous velocity. Now, this type of question will happen when you given the function of r, and the question type, there are two types. The one is you are given the function of r or displacement and asked to find velocity. Or two, you are given the function of v and find the displacement. And for type 2 question, in order to work it out, you need to find the initial condition where, for example, the place or the initial point where the object is at time t equal to 0. So if v is a constant, you can pull it out of the integration and then you get the result that the displacement is v times t. And please remember that this is only when the velocity is constant. Now let's take a look at some example. For example, you run along track with constant velocity of 5 meters per second. Find a distance traveled within 2 minutes. Okay, we must say that this is the straight track, or otherwise the distance or displacement are not the same. So in this case, they ask for a distance, so you don't have to have a vector sign here, sorry. A distance is a constant velocity, so that means direction is constant and time and the magnitude is constant. So in that case, if you're moving in direction of the track is along the x-axis, the magnitude of the velocity is 5 and the time, which is 2 minutes or 120 seconds. So the displacement that given is 5 times 120 or 600 meters along the x-axis. Now in this case, because it is a straight line motion with constant speed, that means you're moving in one direction only. So in this case, displacement, the magnitude of displacement and the distance are the same. Sorry. Now, we start with another case of this problem. Suppose the object has the velocity that changes with time. For example, an object starts moving from origin, okay, and move along x-axis with velocity that change with time such that v is 5 plus 2t in I-axis meters per second. So in this case, what does it mean? It means that the objects are moving along the x-axis with velocity that keep increasing. So at the beginning, when t equal to 0, the object has this velocity of 5 meters per second along the x-axis. And then it increased by 2 meters per second for every second pass. So that is the meaning of this. So the question asks A, find the position of an object at any time t, and B, find the displacement of an object. between t equal to 2 seconds and t equal to 3 seconds. Now, they are different when you say position at any time t and displacement between t equal to 2 and 3. So let's take a look at this. The question states that an object starts moving from origin or position vectors, initial position vectors is 0. So we get displacement equal to Rf minus Ri and equal to integration of v dt. Ri is 0 according to the statement given by the question. So Rf, the position of an object at any time, is an integration of v dt or integration of 5 plus 2t dt in the direction of I. So I can pull it out. So integration of 5 plus 2t, 5 is a constant. So integration of constant at dt anytime give you 5t. Integration of 2t dt give 2t squared over 2. So 2 and 2 cancel. So after the integration, what you get is that the position vectors of an object is 5t plus t squared I. That is the position vector of object at any time. So you see that at t equal to 0, it is 0, and that is in initial position. Now, question B asks, find the displacement of an object between t equal to 2 seconds and t equal to 3 seconds. Now, in order to work this out, we must find that what is the position of an object at t equal to 2 and what is the position of an object at t equal to 3. So what happened is S equal to R3 minus R2, and when you substitute the time between 2 and 3, we find that at R3, the position is 5 times 3 minus, this is plus 3 squared in the direction of I. And then the position at 2 is 5 times 2 plus 2 squared. And that 2 subtract each other along the I-axis. The first parenthesis, 5 times 3 is 15, and 3 squared is 9, so it's 15 plus 9. The second parenthesis is 10, 5 times 2 is 10, and 2 squared is 4. So at t equal to 3 seconds, the position vectors of the object is at 24i. And when I equal to 2, at 2 seconds, the position vectors of the object is at 14i. So between the two time, between 2 seconds and 3 seconds, the object moved by a distance 24 minus 14 or 10 meters along the I-axis. So that is the displacement between the two. So let's spend about 5 minutes practicing this question, practicing the question. An object is moving from origin with velocity of v equal to 10 minus 2 ti meters per second. Find the position of the object at any particular time and when will the object stop after the initial point and where does it stop? Okay, let's try it for 8 minutes. I will give you a solution at 11. let's work it out, and we'll come back after you finish. Okay, let's take about 5 minutes working this out. So, anyone finish the question?
Yes.
Okay. Okay, let's see. Okay, let's see if this works. Okay, it says an object is moving from origin with velocity of v equal to 10 minus 2 ti meters per second. Let's record. So in order to work this out, we start with this. If minus ri is integration of v vector v dt from I ti to tf. So in this case, at any particular time, so it's v dt from 0 to any time t. They said find position of the object at any particular time. So at first they said the object is moved from origin. Start from origin. That gives you that Ri is 0. So we get Rf equal to, take a unit vector out, and then you integrate from 0 to t of 10 minus 2t dt. Now that's the same as the question we have before, Rf equal to, well, integration of 10 dt give you 10t minus by 2t squared over 2 in the direction of I. So that actually, to make it more clearly, it is integration of 10 dt from 0 to t minus integration of 0 to t of 2t dt, two terms, and then you work it out. So what happened is that Rf is actually 10t minus t squared. I. And that's a unit of meters. This is unit meters. Okay, that is the answer. Now, what happened is that that's answer to part A. Find the position of an object at any particular time. To answer part B, okay, when will an object stop after the initial point, and where does it stop? So object stop means, what is the meanings of object stop? It means that velocity is 0. And to get velocity of 0, we got 10 minus 2t I equal to 0. Or you got t equal to 10 over 2, or 5 seconds. So it will stop at t equal to 5 seconds. When t equal to 5 seconds, okay, the next question is that when after the initial point, and where does it stop? Well, the position vector at 5 seconds is actually 10 times 5 minus by 5 squared I. And 10 times 5 is 50. 5 is squared is 25. So 50 minus 25 give you 25 I meters. So the object will moving along the x-axis, and then it's slowly, and then it stopped at 5 seconds after the initial point. And then at that point, it is 25 meters from origin. So how many of you work it and get the same result as the solution?
Yes.
Okay.
Yes.
This is practically almost the same type as the quiz or the exam we're gonna have. Okay. I still cannot figure out how can we work out the exam, but that is practically almost the same. So we're going to our next topics, which means acceleration. Now we have velocity. Now what is acceleration? Acceleration is the rate of change of velocity. Now in terms of acceleration, we don't have a terms that are scalar motion of scalar function of it. The acceleration is the rate of change of velocity, and that means vectors. Okay. And when we say that average acceleration, that means the change in velocity over time. So let's say that suppose, let's get to the laser pointer. Suppose we're starting here with using this thing as maybe better. If we're starting at that point with initial point Ri, and at that point, the object is moving with velocity Vi. After the time passed by delta t, the object moving to point F, having a velocity Vf and having a position vector Rf. Now you see that this is Vf, instantaneous velocity of an object at that point. It is tangential to the path Now Vi is moving here, so this is Vf, this is Vi. So the velocity changed by delta V, which is the red vectors here. Delta V is actually Vf minus Vi, and the delta T is the time between the 2 points. So within Tf minus Ti, within delta T, the object changed its velocity by delta V. So by definition, the average acceleration is the rate of change in velocity over the time. So it's delta V divided by delta T, or Vf minus Vi over Tf minus Ti. And that's the definition of the average acceleration. However, if you continue to reduce the time delta T to 0, after you reduce that by some point, the acceleration will become instantaneous acceleration. So it's the rate of change of velocity when the time change is approaching 0. In that case, a instantaneous acceleration, or normally we would say just acceleration, is limit of delta t approaching 0 of delta v by delta t. Or in calculus, it is dv by dt. Now the unit of acceleration is meters per second, and then divide by another second. So you've got meters per second square. Sorry. Now, normally we can find the acceleration by using Newton's law. Because Newton's law states that the acceleration of the object is proportional to the net force acting on an object and inverse proportional to the mass. So by using acceleration laws on Newton's law, we can find the acceleration of an object. So from the example or the quiz that we have just a minute ago, the velocity is 10 minus 2 ti meters per second. By definition, the acceleration is dv by dt. So it can be proved that d by dt of 10 minus 2 ti can give you the acceleration of minus 2 meters per second square in the I direction. And in this case, acceleration is constant. Okay, this is instantaneous acceleration. It is constant by minus 2. So this is the condition from the last quiz. So for an object with constant velocity, the acceleration will be some 0 because the velocity doesn't change over time. Now let's move on to another example that is more complex. This one is an object is moving in rectangular coordinate with position vectors that represent by r equal to t cubed plus 2t squared plus 5t plus 1i and plus t squared plus 2t plus 1j and 5k. So this is a little bit more complex, and that means it's moving in three dimensions. It's moving both x, y, and z axis. Now, the question asks, what is the velocity at any time t, and what is the acceleration of an object? Okay, are they constant? And what is the initial position and initial velocity? So that means the position vectors that are equal to 0. and the initial velocity, the velocity at t equal to 0. Okay. So let's give you a minute to think this through. Okay. Let's figure out if you get this question, what will you do? Step by step for like a minute. Okay. Let's say this. This is a little bit difficult. Okay. By definition, the velocity is dr by dt. So you can plug it in. Velocity is I, which is a constant vector. Now it's d by dt of the x component, which is t cubed plus 2t squared plus 5t plus 1, plus j direction d by dt of the y component, which is t squared plus 2t plus 1, and then plus k of d by dt of 5. And we know that the derivative of constant is 0. So for k direction, there are no velocity. Now for I direction, you give v equal to I times derivative of 3 cubed is 3t squared. Plus derivative of 2t squared is 2 times 2t, so it's 4t. And derivative of 5t is 5, derivative of 1 is 0. So for x component, the velocity is I times 3t squared plus 4t plus 5. And along the y component, it is the derivative of t squared give you 2t, the derivative of 2t give you 2, so it's 2t plus 2, and then plus 0k. Now you see that velocity is not constant, it changes with time. So that means that it has an acceleration. So this is the formula that we use more frequently in calculus. D by dx of x to the power of n is nx to the power of n minus 1. Take another derivative, you get the acceleration of equal to dv by dt. So in the I component, derivative of 3t squared give you 6t. And derivative of 4t give you 4. So it's I direction is 6t plus 4 in the x-axis. And in j-axis is derivative of 2t plus 2 is only 2. And 0k. So that is an acceleration. So the object is moving also not with constant acceleration. So in that case, the next question asks, what is the initial position and initial velocity? So we get to the position and then substitute by t equal to 0. You see that when t equal to 0, r equal to 1i plus 1j and plus 5k. So that is the initial position, 1i, 1j and 5k. And initial velocity, we plug in t equal to 0 in this case, v equal to 5i plus 2j and plus 0k. So it has some direction in x and y axis. K is slipping out from. Now let's talk about special case, but it is the case that you find more frequently. For constant acceleration, in that case, when we say that if A is constant, for example, if A is a gravity, the gravity in case of gravity, A is minus g k. Okay. It's point downward. Usually the height, the z-axis or the z-axis is used more along the height from the ground. So it is minus gk. And there are many other cases where acceleration is constant. For example, the car moving with constant acceleration. Some animals can run with constant acceleration. That depends on the question that were given. But if A is constant, because A equal to dv by dt or dv equal to a dt, so you're doing an integration from initial velocity to final velocity from 0 to t, you got Vf minus Vi is at, or this is also can be written as Vf equal to Vi plus At. Or some of you might know as V equal to U plus At. And I still have the vector symbol on. Now take another integration, because by definition V velocity is dr by dt, or dr is equal to v dt, and make integration from Ri to Rf of this equation. Okay, we got the displacement S as Vi times t plus 1/2 At squared. This is the constant acceleration. And I have to remind you that this equation is correct only with constant acceleration. This is very important. If acceleration is not constant, you cannot use this formula. Okay, you cannot use the formula that is circled into red one. Now, you can work more by substitute the time from the first equation into the second equation. And what you got is that the Vf squared minus Vi squared is equal to 2a dot s. or S equal to Vf plus Vi times T over 2. Okay. So let's take a look at some example in this case. This is a typical question you can find in the book. It says, a man driving a car at constant velocity of 30 meters per second, and then he run a red light. Okay, a police car at the intersection chasing him 2 seconds later from rest. So the police car initially is at rest with an acceleration of 5 meters per second square. How long will the police car catch up with the man and how far? So let's see a little bit about this in pictures. So the man driving his car at 30 meters per second, which is around 108 kilometers per second. So let's add something here. No, they don't allow it. Every 10 meters per second equal to 36 kilometers per hour. So for 20 meters per second, it is 2 times 36, so it's 72 kilometers per hour. At 30 meters per second, the car is moving at around 108, or 3 times 36, 108 kilometers per hour. So which is quite fast. So he's running the red light with 30 meters per second or 108 kilometers per hour. Now, a police car saw he run the red light, so he started an engine and start to move. So by the time he start to move out from the intersection, it is already 2 seconds. So in that case, the man is moving away by 60 meters. So when the police start moving, the car is at 60 meters ahead of the police car with velocity of 30 meters per second. The police car chasing with initial velocity equal to 0, but acceleration of 5 meters square. So if we work this out, let's say t is the time from starting until the police car catch up. So the SP is the displacement of the police car. Will be UT plus 1/2 AT squared because he's moving at constant acceleration. And because the police car start from rest, U equal to 0. So SP is 1/2 AP squared times T squared. And that is equal to the distance that the car is moving further from 60 meters. So at that point, the car is already at 60 meters ahead. So when t is the time that passed, it's also moving with its own velocity times t. So we see that SP equal to 1/2 APT squared must equal to 60 plus UCT. and you substitute the number given by 1/2 of 5 meters per second square times t square equal to 60 plus 30t. Divide both sides by 5 and multiply by 2. What you get is t squared is 24 plus 12t. So it is t squared minus 12t plus 20 minus 24 equal to 0. Now, last year I'm hurry up and working this one because it's almost time, and I make a mistake. So if you take a look at this handout, you will see that from this point is when I make a mistake. I didn't erase it out. But in this video, I did erase it out so that I'm not confusing. So we will go on to the next page to solve it out. So when we work this, we end up at t squared minus 12t minus 24 equal to 0. Now, in order to work this out, you need to use in a equation. Let me get off from this. We need to use a solution. Let's write it somewhere here. For ax squared plus bx plus c equal to 0, we use x equal to minus b plus minus square root of b squared minus 4ac over 2a. So we have that equation of t squared minus 12t minus 24. In that case, a equal to 1, b equal to minus 12, c equal to minus 24. So from that expression to find the x, the t is actually 12 divided by 2. So it's minus b, so it's minus of minus 12, give you a positive 12 divided by 2. Plus and minus of square root of 12 squared. Divide by 2a, put it inside parentheses, it gives 4. And then minus by 1 times minus 24. Because a and a cancel, 4a and a cancel, 4a cancel. So what you get is 6 plus and minus of 12 squared is 144 divided by 4 give you 36. And then this is negative, the negative sign give you plus. Okay, and because a equal to 1, so it's plus 24. So it's 6 plus or minus of square root 36 plus 24. And 36 plus 24 is 60. Square root of 60 is 7.75. Because 7 times 7 is 749, and 8 times 8 is 64. So square root of 60 is between 7 to 8. So it's 7 plus 7.5. And now you will see that there are 2 times limit here. Times equal to 13.75 seconds and minus 1.75 seconds. And the negative sign is not the answer because we know that we start from t equal to 0 and it must be positive to catch up. So this one is not the answer. Now, in order to check if it's true, you can do it by substitute it into the first question, because the distance the police car is traveling is 5/2 t squared. So it's 5/2 times 13.75 squared. It is 472.37. Just comes straight from the calculator. Or you can see that the distance of the car is 60 plus 30t. So 30 is times 13.75 and then plus another 60 give you 472.5, which is the reason it's not exactly equal is because in order to do a square root and then add up, we do some round up of the numbers. So it is not quite exact, but at least it is correct distance by the order of half a meters. And at that time, the speed of police car will be v equal to u plus at, and then it is 5 times 13.75, it is 68.75 meters per second. And my remarks for that is it is too fast. The police car is driven at 247.5 kilometers per hour. Only one time in my life that I see this car moving this fast is from a closed circuit TV on the expressway above the Kasetsart University almost 10 years ago, where the white Civic crashed with the van, causing 9 people died, 9 deaths. Okay, I'm referring to one of the famous case in history. Okay, and that at that time the speed of the white Honda Civic is almost 200 kilometers per hour. So 247 kilometers per hour is doable but not recommended. Okay. Now for next step. In this particular question of constant acceleration, as I mentioned before, that the case where gravity, okay, gravity is one of the cases where the acceleration is constant because the Earth pulls every object with constant acceleration. So Galileo proved that when he dropped a bigger stone and a smaller stone from the top of the Leaning Tower of Pisa, he stated that the two objects will going down with the same acceleration. And that is just being proved exactly for us to see. I think just a few years ago, there's a clip on the drop of a bowling ball and a feather inside a vacuum chamber. And it exactly shows that without air resistance, every object falling from the same height will reach the ground at the same time. So the acceleration of gravity is constant. Now, in order to work that problem out, we need to be careful about direction. So there are some suggestions here. when you're working the problem of gravity on the object moving along the vertical axis, let the direction up to be positive and down to be negative. And if the velocity is up, we say that the velocity is positive. And if the velocity is point downward, it is negative. Now, if the result come up as a positive displacement, it means that the object is higher than the original point. And if S is negative, it means that the object is lower than initial point. And the gravity itself or the acceleration is always negative. Okay. And in this case, the actual value of gravity is 9.81 meters per second, point downward. And that is the average value. Actually, value of gravity on Earth are not equal. They are maximum at the pole and minimum on the equator. But if you're doing around 2 decimal places, you don't need to use the exact value. You can use the average value, which is about 9.81. But in some cases, in some books or in some cases of the exam, because 9.81 is close to 10, sometimes they use approximation that the gravity is minus 10 meters per second square for the simplicity of working the math. However, please understand that nowhere on Earth have the gravities of minus 10 meters per second. The maximum value on Earth that we encounter has a gravity of 9.8 meters per second. In Thailand, where we are closer to the equator, the gravity is 9.77. Okay, we have about 5 minutes. Let's take a look at another example, which used to be a quiz. Okay. Well, the quiz said that a rock is thrown up from a cliff with velocity of 10 meters per second. Find the highest point that the rock reached, and when will it hit the ground at the bottom of the cliff? So this is a very simple question according to gravity. And also said that use gravity equal to minus 10 meters per second squared. Now, in this case, we say that the rock is going up, so the initial velocity u is plus 10 meters per second. And at maximum height, the velocity must be 0 because the rock will going up and then the gravity will pull it down until it stopped. And we use a simple equation of v equal to u plus at, and v is 0, u is plus 10 because it's going up, a is minus 10 because its gravity is always downward, times t. So it's found that the rock is stopped momentarily at 1 second after it was thrown up. So the distance that is going up is s equal to ut plus 1/2 at squared, and equal to 10 times t plus 1/2 of minus 10 t squared. Substitute t by 1 gave you an s equal to 10 plus 1/2 of minus 10 times 1 square, or minus 5. So what it gives you is 10 minus 5. So the rock is 5 meters above the starting point. And because the starting point is on the cliff, that is 20 meters from the bottom of the cliff. So it is 25 meters from the bottom. Now to find the time that it reached the bottom is s equal to minus 20 meters because it is lower than the initial point. Now s is ut plus 1/2 at squared. Substitute s to be minus 20 because it is lower than the initial point. U is still positive, plus 10t, and plus 1/2 of minus 10t squared. And you get the expression of 5t squared minus 10t plus 20 equal to 0, or t squared minus 2t minus 4 equal to 0. And you can say that the t is using the same expression, get the time of 1 plus square root 5 seconds, or 3.23 seconds. Okay. Another way to solve it is to using from the maximum point. So the maximum point is when the object is at 25 meters above the ground. So s is 25 meters, u is 0. So it gets t equal to square root 5 seconds from the highest point. So the time will be 1 plus square root 5. Okay, let me stop sharing, stop recording here, and stop sharing. So here's the quiz today. You have 15 minutes to work it out. After you finish, work it out and submit, you can leave the meeting and see you again tomorrow. Okay, let's start the quiz for today.